Okay, so today we're doing 5-3. Like I said, it is out of order. So in 5-3, we're going to go over medians and altitudes of triangles. And then we will do 5-2 tomorrow. So both of these have a lot of vocabulary. So make sure you are studying your vocab so you know what a median is. That's the first thing we're going to talk about today. So whenever you're given like a definition, right, you could see I highlighted some things on there. So not only are you just filling it in, but you have to read what you're filling in, okay, or else you're not going to have any context at all. So it says that the median of a triangle is a segment whose endpoints are the vertex of a triangle and the midpoint of the opposite side. So if it's a median, then it's going to be a segment where the endpoints are a vertex and the midpoint of the opposite side. And then I drew an example here for you. We're actually going to draw a triangle that has all three of them. So because a median goes from the vertex, remember the vertex is where your two ends come together. So A, B, and C, those are the vertices of a triangle, of this triangle. And since each triangle has three vertices, there are three medians for each triangle. Okay, so since each triangle has three vertices, there are three medians for each triangle. Okay, so pictured above is one median. We'll highlight that, and then like I said, we're going to draw another triangle and draw all of them. Okay, so for this triangle that is labeled BD is the median. Okay, so this is one of the medians of this triangle. Now notice that it goes to the midpoint of the opposite side. The way that we show that this is a midpoint, because remember the midpoint is going to cut this in half. It's a bisector, okay? We can show that these two segments are congruent. So that's why these two notations here are very important. Okay, so this is what's showing you that D is the midpoint. You won't always have that part labeled. Sometimes you'll have to draw them in yourself. All right, so let's draw our own triangle. And we'll draw all the medians of that triangle. I'm just going to use a straight edge. And the reason why I want you to draw your separate triangles, I want you to see all of them together, but I also think it's helpful for you to just see one piece. Okay, so that's what one median is going to look like, and then we're going to draw an example of what all the medians would look like. Okay, and your triangle does not have to look exactly like mine. I just wanted to draw it similar to what we had here. Okay, and we are going to call this ABC. All right, so a median starts at a vertex and then it goes to the midpoint. So like we just said, there are three vertices, A, B, and C. So for this one, I am going to just eyeball it. It has to go to the midpoint. So I'm going to draw where I think the middle of this is. And then if it's a midpoint, then I need to label it like this. So if this is the midpoint, I know that those two are going to be congruent. And then I'm just going to call that midpoint D. Okay, so AD is a median. Now remember we said there are 3 medians. So I want you guys to go ahead and I want you to draw the median from the vertex of B. Okay, and then when you're done with that, go ahead and do C. And while you guys are working on that, I'm going to pass out straight edges if you guys need them. Okay, so just like we did for that one, you guys should have made a mark here. Now, you don't want to use one dash because we don't know if these two are congruent to these two. So we are going to use 2 dashes. Okay, and then you guys should have your 3rd one as well. Okay, so from C, and again, you are just eyeballing this one, and then I'd have 1, 2, 3, 1, 2, 3. Again, you don't want to use the same mark because you don't know if the other sides are congruent. And then I just called mine, since this one was D, I called this one E. Okay, so BE is a median. If you called this something different, that's fine. And then so I called this one F, and CF is a median. Okay, now once you drew all 3 of those, hopefully you guys noticed that they should have intersected inside the triangle. That point is called a point of concurrency. Okay, so the point of concurrency of the medians of a triangle is the centroid of the triangle. Right, so a point of concurrency is the center of gravity. So if you were to balance this triangle, if you had this triangle, you wanted to balance it on your finger, if you put it at the centroid, that's where it would balance. Okay, so the point of concurrency is the center of gravity. Okay, so the point of congruency is the center of gravity. That is the point where the triangle will balance. And then here we see the centroid is always inside the triangle. Okay, and that's important because as we start to deal with some new vocab terms here, some new parts of the triangle, not all of them are always going to be inside the triangle. Okay, so you have the median, where all the medians meet is called the centroid, and that is always inside the triangle. So we're just going to draw a little diagram here. So the median, I'll say the medians, meet at the centroid, and the centroid is always inside the triangle. Okay, so just something that you can glance at quickly. The medians, when they intersect, they make the centroid. The centroid is always inside your triangle. All right, now you have a special theorem with your centroid, and that tells us that the centroid of a triangle is located 2/3 of the distance from each vertex to the midpoint of the opposite side. So the centroid is located 2/3 of the distance from the vertex to the midpoint of the opposite side. So as I'm looking at this drawing, I can see that P is my centroid. Okay, so we're just going to write that down. So point P is the centroid in this drawing. Okay, so this is located 2/3 of the distance from each vertex to the midpoint of the opposite side. So we're going to look at a couple things here. I think the easiest one to look at is BY. So if you're looking at this length, BY, BP is going to be 2/3 of that length. Okay, and BP is going to be 2/3 of the total length. So one way that you can think of that is that segment, BP, that length, is going to equal 2/3 of the total length. Okay, so from the centroid to vertex is 2/3 the total length of the median. Now you can tell that this is a centroid and that these are medians based on these marks. So I know that Y is a midpoint because each of these sides is congruent. I know X is a midpoint because each of these are congruent, and I know Z is a midpoint because each of those two sides are marked as congruent. So to figure out what 2/3 is, if you know the total length, you can multiply that by 2/3. Now that happens with every single one of these. So if you look at your median here, so we just looked at BY, now we're going to look at AX. Okay, so AX is the total length. We would say that the distance from A to P is the distance from the vertex to the centroid, and that would be 2/3 of the total length. Okay, so see if you can write the third one. For this, and then we're going to talk about one more thing. Okay, so see if you can go ahead and write the third equation. Okay, so based on those two equations, see if you can write the third one. It is, but we're just talking about midpoint. Okay, Nia, you want to tell me what you got for this one?
I got CP equals 2/3 of CC.
Good. And I just said, yeah, good. All right, now, some of you may have already noticed if you have BP is 2/3, then what's PY? Then PY is going to be 1/3, right? Because together that would make 3/3, which is the whole. So that's something that you can also use, is that PY is 1/3 of the entire segment. Which means if this is 1/3 and this is 2/3, if I know this segment, I can do what to find BP? Multiply by 2, right? Because 1/3 times 2 is 2/3. Rachel.
If we didn't know us what are the lengths of PY, could you do YP equals 2/3 and A?
Well, YP wouldn't equal 2/3, but YP would be 1/3.
Well, I mean if we didn't know which one was which, could we flip them?
No. What do you mean if you don't know which is which?
If we didn't know that BP was 2/3 and we didn't know that PY was 1/3, could we switch them to be BP is 1/3 and PY is 2/3? Just switch.
No. So because of this theorem, you're always going to know that from the vertex to the centroid is 2/3. So no matter what, you don't know what it's 2/3 of because we weren't given any other lengths. But whatever the length of the median is from the vertex to the centroid will always be 2/3. From the centroid to the rest of the length to the midpoint will always be 1/3. We just don't know, in this case, 1/3 of what. So that's what our next example is going to investigate. So in this triangle, LMN, you have RL, that's 21, okay, and you have SQ, that is 4. And then it tells you to find each length. So we have to find LS. So first, make sure that you understand in the picture, if they are giving you these marks, it means these are all midpoints. And because they go from the vertex to the midpoint of the opposite side, this is going to be your centroid. So S is the centroid for this case. Now they give you the length of RL, and RL is a median. Okay, so RL is 21. That is a median of the triangle. And then they also give you SQ. And SQ is right here. That equals 4. So from SQ, this is going to be from the centroid, not to the vertex, but to the midpoint. So this goes from centroid to midpoint. which if we look up above here, right, centroid to midpoint, is 1/3 of the median. All right, so then we have to find LS. In this case, LS is going to be just like BP here. So your LS is going to equal 2/3 of your median, which is RL. So we can take our length for RL, which is 21, and multiply it by 2/3. And then I'll talk to you about another way you can think of this. So we're going to do this without a calculator. Whenever you're multiplying these together, there's a couple ways you can do it. You can do 2/3, and then remember, any whole number is just over 1. So you could go straight across. 2 times 21 is 42. Then you could do 42 divided by 3, so that's possible. But whenever you're multiplying, it's like you're dividing these two numbers. And if you were dividing 21 by 3, what would you get? 7, right? So this would be 7, this would be 1. 2 times 7 would be 14. Okay, now like I said, if you didn't think to simplify, you could do 42 divided by 3, which is still going to be 14. Okay, so your length for LS is going to be 14. All right, now we have to find NQ. So notice that NQ is the length of the median. Okay, you are given SQ, which is 1/3 of the median. If SQ is 1/3, how can I find the total? Okay, why would I multiply by 3? Yeah, okay, so if it's 1/3, it's 3 parts, right? So if I take 1/3 multiply by 3, that's when you get the whole. Okay, so that's what I would do. I would end up doing 4 times 3. You can also think of it as, you know, if you can figure out what NS is, NS plus SQ. Okay, so SQ you know is 4. You know NS is going to be 2/3 of your NQ value. Really, I would do 4 times 2. I'm going to show you, I'll show you how to solve this actually, using mathematical symbols, and then we'll do what we just talked about, because that's really how you're going to do it. So if you use the theorem, you know that NS is 2/3 of NQ, your total length. If you were trying to solve this, what you could do is you could subtract 2/3 NQ from both sides. This is a little bit of a different way of thinking. So if you have NQ and you minus 2/3 of it, what do you have left? Because what's really in front of the NQ? 1. 1 minus 2/3 is 1/3. So just like what we were talking about, you can take that value and multiply each side by 3, which means 12 would be NQ. Okay, like I said, I think of this in parts. So if this is 1/3 and it's 4, this is 2/3. Isn't 2/3 consist of 2 pieces of 1/3? So 4 times 3 would be 12, and that would be your NQ. Okay, so it really is helpful to think of it as fractions. I know some of you are not fraction fans, but if you can split it up into a third, then you can figure out what your median is. All right, and then we are gonna talk about one other piece of the triangle today. So just like this piece, the median goes with the centroid, we're going to talk about another piece that is also going to have a special name for the center. All right, and then on the back it says, and blank. Okay, it is an altitude. Do you guys know another name for altitude? The what? Yeah, the height, right? So an altitude of a triangle is a perpendicular segment. This perpendicular segment is going to go from the vertex to the line containing the opposite side. Okay, so it's important to remember that when we have a perpendicular segment, Matt, that means that there's going to be what? A right angle. Okay, so just like the height always has to have a right angle, the altitude is the same way. Now, a lot of times when we think of the height, we always think of like the top to bottom, but that's not always the case. It just has to form a right angle with a vertex and the opposite side. So every triangle is going to have 3 altitudes, just like it can have 3 medians, but the location of these altitudes can be either inside the triangle, it can be outside the triangle, or it can be right on the triangle. Okay, so it's either inside, outside, or on the triangle. The point of concurrency of these is called the orthocenter. Yep, it's called the orthocenter. And we are going to be drawing those in here. Okay, so for this triangle, we're going to go ahead and draw the altitude. Now, when you are drawing your altitude, it does not say anything about going to the midpoint. If I drew this line here, right, that went to the midpoint, is that going to look like a 90-degree angle? No. Okay, now like I said, we are just going to eyeball this one. You guys might want to use a pencil first and then go over it. So let's first take R. Do you guys have like a faded line on yours? You can probably see X. That's where your altitude is going to be. We're going to draw that. Okay, so what you want to do is draw this so that it forms a 90-degree angle. Like I said, we are going to eyeball that. You do have that point X on there. And then go ahead and put your right angle symbol on there. Okay, and that's going to be our first one. So our altitudes. The first one that we drew was Rx. And then we are going to draw our others. Okay, so the next one I'm going to draw is going to go from Q. So what I'm going to do is I'm just going to line it up with the vertex here. So it has to go to the opposite side. It has to form a 90-degree angle. So I'm going to estimate where I think that 90-degree angle is. And I'm going to put my right angle on it, and I'm going to call this one Y. Okay, so then my next altitude is QY. And then I'm going to draw my last one. So from S. So again, remember, you want that 90-degree angle. So I'm looking here to make sure that I do have a 90-degree angle with RQ. And then I called this one Z. Okay, so SZ is my third altitude. Now, if you look at your picture, you have formed the orthocenter. Okay, so that is the orthocenter. And then just like we did with our summary on the first side, we'll do this one too. So the altitudes, when they meet at the orthocenter. And the orthocenter can be inside, can be outside, or it can be right on it. Okay, so inside, outside, or on the triangle. Okay, now if you're looking at this one, we can see that it is where? Inside. So for this one, orthocenter is inside triangle QRS. Now we are going to draw some other orthocenters below. So we're going to investigate some other types of triangles. Okay, so the first type of triangle, first of all, if you guys were to classify this triangle, what would you classify it as? By its angle measures. No, what is it? A Q, right? Angle Q is acute, right? It's not right. We can tell it's not greater than 90. Same thing with R, same thing with S. They're all acute. Okay, we are going to draw an obtuse one next. So in an obtuse triangle, you just have to have one angle that is greater than 90. You guys have any predictions on where this one's going to be? Or do you have any predictions on where it's not going to be? Okay, let's see. Could be outside. Yeah, probably not going to be inside based on what we just talked about. Okay, so I have my triangle. We'll go with the ever popular ABC. So if I'm going to find the orthocenter, and let's go ahead and label this. So these examples, we are going to find the orthocenter of an obtuse triangle and a right triangle. Okay, so we know that this one is obtuse because angle B is greater than 90 degrees. What I have to do now is draw all the altitudes. Okay, so go ahead and draw just the altitudes for, oh, that'll be hard for you guys to do. Let's draw the altitude for B. Okay, so if I'm going to draw the altitude for B, if I look at the opposite side of B is AC. So that I can do no problem. Now, if I want to draw the altitude for A, I want to draw it to BC. But look at this, right? If I want to draw this for BC, if I go from A to B, is that going to be a right angle? Nope. Is really anywhere on here going to be a right angle? No. So what you have to do is just extend this side. So that's what we're going to do. So I'm going to take my pencil and I'm just going to extend this with a dashed line because it's really not part of the triangle. But you do have to draw the right angle to the opposite side. Right, so if I extend this part of the triangle, then I can draw the altitude. So sometimes you guys may have actually seen this in the past where there is that dashed line when you're finding like the area of a triangle. You may have seen something like this in the past. This would be the altitude for vertex A. Okay, so this would be the height of that triangle. All right, now we're going to do the same thing for C. So C has to be drawn to AB. But if I go to do that, I don't have a right angle. So just like I extended BC, I also need to extend AB. So I'm just going to do that with a dashed line. And see how I line it directly off there? Okay, and then I'm going to draw that piece. I'm not going too fast, am I? You guys are with me? Okay, so then if I'm going to draw the altitude now, again, remember I want a 90-degree angle. Okay, there I am. Now, if I'm going to find the orthocenter, what has to happen with all those altitudes? They're going to have to meet. Do they meet yet? Nope, that's okay. All I have to do is extend them. Okay, and I'm going to use different colors to extend them just so you guys can see the different lines and where they're meeting. Okay, so I'm going to go ahead and I'm going to extend B first, since that's going to be in the middle. And again, when I extend it, I'm just going to use my dashed line here. And if you extend it the first time and it still doesn't meet, that's okay. You can always go back and extend it again. Okay, so it looks like those two are meeting, which means if I extend C, should meet in the same location. Now, you can see even with mine, my C, if these aren't lined up right, are they going to meet in the same place? Nope. So even mine could use a little tweaking, right? And then you can see I just kind of tweaked this one a little bit. And then yay, they all meet. Okay, so this is where my ortho center is. And were our predictions right? Is it outside? Yep. So if it is an obtuse triangle, where's the ortho center? Outside. Yeah, it will. And if it's acute, where is it going to be? Inside. So when we do this for a right triangle, where is it going to be? It'll be right on it. Let's see what that looks like. Alright, so we're going to draw a right triangle. Again, you are eyeballing this one. You can always construct it with your protractor. If you eyeball it and it is a little bit off, we're going to know when we go to construct our orthocenter. Okay, so this is a right triangle. So again, you always want your altitude to go to the opposite side. And this one's going to look a little bit different, like I said, because it is going to intersect on the triangle. So from B, I'm going to construct my altitude. Now, when I construct from A to B, from A to B, or not B, but A to BC, see how this length is already perpendicular here? This is going to be your altitude. In fact, I will use a highlighter. Okay, so A to B, that is your altitude. This is your altitude. Now if I go from C to BA, where's the perpendicular segment? From C to B, right? So the orthocenter is where? At B. Okay, so if it is a right triangle, the orthocenter is on the triangle. And where does it occur? Occurs at the right angle. Okay, so it occurs at the vertex with your right angle. Okay, so your homework for 5-3 is page 317. And again, just remember that we're doing 5-3 first. We are going to do 5-2 tomorrow. And I would start just studying your vocab now. That tends to be the most difficult part of the quiz. And then I'm going to put up the calendar here in a second too, so you guys can see where we're at for the rest of the week. Okay, and then you guys can start working on this.